Good day to everyone. Hope that you have a beautiful day ahead of you, and we appreciate your time. We're very fortunate to have two guest speakers on today. As we run through the agenda list, my name is P.T. Jones. I work for Oak Ridge National Laboratory, but I'm on a detail supporting the United States Department of Energy. And one of the tasks that I do there is the IEA tasks for electrified roadways and another IEA task for electrified port activities that help to decarbonize freight. This focus of this seminar or this webinar is the electrified roadways. And as I mentioned, we're very fortunate to have with us two speakers that will bring a different perspective and insight. And we also have enough Q&A time that we hope to have some engaging discussion. It is a recorded session, so please don't say anything that you don't feel would be good to have out later. We'll go through just a few housekeeping rules, some introductions to the TCP itself, and then we'll go on and start the discussions with Niels and with Jan. The TCP itself has been around since 1993. Oh, well, excuse me. Housekeeping, yes. All attendees are muted. Please introduce yourself in the chat. And along with doing that, you might want to type in your email. That would help if anyone else on the webinar likes something you made a question or a comment about, or they want to contact you. Also, we can contact you later on. Please post your questions in the chat, not in the Q&A. We know that's a little bit of the navigation issues, but we apologize for the difficulty. It's just easier for us to track one window. And as I mentioned, this event is being recorded. I will need to dance around back and forth just a little bit on the slides, but hopefully we can work through this and get the information out that you guys need to make contact with us at a later time if necessary. So the TCP itself has been around, as it says here, since '93. And as I was looking at some things preparing for this, I realized that was actually earlier than the first hybrid vehicle production scale from Toyota, which started around 1997. So the HEV TCP, as it's spelled out here, Hybrid and Electric Vehicle Technology Collaboration Program. The IEA has many TCPs, but this one in particular starts to really bring in the different difficulties and benefits of a fairly unique, even though now it seems mainstream, vehicle architecture. It's expanded to understand grid impacts, everything from battery swapping to diesel electric vehicles, which we'll get onto in a minute. It operates as part of the larger IEA contingent, and there are 18 countries represented in the HEV TCP, which we're very fortunate to have 9 participate in this task, which is somewhat remarkable in and of itself that we have this much breadth. But as you'll see from the discussions later on today with our speakers, we also have some very valuable insight from different perspectives. As I mentioned, there are many tasks within the HEV TCP. You can get to that website, ieahev.org, and look at all the different tasks. Right now, there are about 10 or 11 that are active. Some of them are just starting up their websites. Everything from, as you see here, just the raw materials and processing and links and issues, as well as battery swapping, which of course has been renewed in interest, given the new opportunities both with batteries and standards. It really starts to impress upon everyone the importance of standards as we move forward in all different realms of sustainable transportation. We're going to walk through a little bit of research from both of these gentlemen and their experience, and then we're going to also understand, what's the situation around electrified roadways, and not just why it's of huge benefit potential, but also, I'm seeing the chats pop up here, but also to see if there are ways where we can identify what it means to have a deployment that's beyond just a pilot project, right? What's really going to grab the attention of governments and of participants and people who may be interested in enacting an electrified roadway, even if it's for a small deployment, but one that would be fairly consistent. We've already seen these places in areas like mining operations where they have their own. They're up and running now, Obviously, it's a little bit different situation than a traditional um, um, transportation system where you're interacting with a lot of different public vehicles. So the HEV TCP, as I've said, funds or is the organization for Task 45. Jan will go over a little bit of these different details for the technologies, but we have four main technologies of interest. From the left, we have the catenary systems, and we actually have two forms of catenary system. There's catenary systems for highway, and then there's catenary systems for inner city. And the difference there would be more like a bus system for low speed, and then the catenaries for the high speed. And they actually do use different standards, which is in some people's minds a problem. But if you talk to either the folks operating on the pilot deployments or the folks operating on the inner city deployments, which are now stabilized, I think you'd realize that they don't have an issue with interoperability. They simply just don't, operate on the same technologies. Then, as you move to the right, there are ground conductive. So these are conductive tracks that are laid into the pavement itself. Further to the right, the ORNL credit picture shows a dynamic wireless, which would be, of course, usable in any category of vehicle. And then on the last consideration for technologies for Task 45, we have the side guardrail conductive technology. We are now in our sixth term for the HEV TCP itself, and they've already sent and I believe started the process to extend for another term of 5 years. As I mentioned with the TCP itself, we have the good fortune of being related to or connected strongly to Task 47, which had webinars earlier this week as well. And one of the important elements of Task 47 is the focus on port activities, which, as most of us know, demand quite a bit of power and logistics understanding, as for most of our countries, the ports are a hub for economic benefit. The reason that these tasks so well overlie is because as we move forward and understand the impact of sustainable freight, electrified roadways as a technology opportunity becomes a little more realistic. And as we've seen from recent webinars and workshops, most recently in Task 45, we had the opportunity to meet in Austria earlier in the summer, and the Netherlands had reported that they're moving forward briskly on a possible deployment plan. Well, Niels, I now see that there's only one of you.
Yeah, I think I solved the echo problem. Problems are to be solved. And one of the problems is the problem with getting into a sustainable transport solution. And I will present shortly about the ambition from Scania to do this, driving the shift in this direction. And I will try to give you an OEM perspective of how we go into this commitment of sustainability. We also will focus quite a lot on how we aim to have a product portfolio and product and service portfolio that is available to meet industry needs. So hopefully you will enjoy the ride. Sorry. A little bit about myself shortly. Been at Scania for many, many years in the position to date as being a Director of Technical Affairs, position in Brussels from end of last year. A heck of a lot of years at Scania. I think I'm in the same class as PT. You said 3 decades. I'm close to that. Yeah, coming on. I'm in your heels. PD, PhD from 95. That's 19 and 95, vehicle engineering. One of the first from KTH, actually the first one. And been at Scania for all these years and lead of Spearhead technology research and development in various areas, active safety, fleet management, and from 2007, e-mobility. I don't think e-mobility that was even invented as name, electrification. I also have two share positions, share of Swedish Electromobility Center. Proud to say that, been there since 2012. And also co-sharing is standard work on wireless charging for heavy-duty vehicles, which now also include dynamic charging from wireless as being a standard. Very interesting, and need more industry support to that work. Scania in brief, we are sort of past the startup period of the company. 1891 it was founded. But again, I would mention that we are sort of a startup and scale up of the new technologies of electrification. So we more or less, we are now in both ends of this, being a very old company, but also in a completely new ecosystem. We are present in 100 plus countries all around the world. We have 1,500 service points and almost 60,000 employees. And you see the economy, can also say that it is a healthy company. Last read figures, 1934 and 2023 was better than bad years of 2020 during the pandemics. So we have a purpose at Scania to drive the shift towards a sustainable transport system, creating a world of mobility that is better for business, society, and environment. So also in our purpose, you can see the sustainability as the focus of what we do. We have adopted what's called the science-based targets at Scania and have put ourselves into ambition to come to a 50% reduction of the scope 1 and 2, and those are for our own operations. From measuring 2015 to 2025, we aim for a 50% reduction of the CO2 equivalents from our operations, and we are well on the way. However, that is just a couple of percent of the total footprint of a company and our products and processes. So more than 90% comes from scope 3, which is where the products are used. And that's natural because they emit a lot of CO2, fossil CO2 from the use of energy, which is basically has been fossil diesel. We have an ambition of lowering that on the rolling fleet, which is the sales of a year, in each year compared to 2015. 20% in 2025, very close, 2025 is next year. We're quite far from that, but we see that the new introduction of electric vehicles are one of the ways to take us up to this 20, but it will be a struggle. This is the most important part in the reduction of the footprint, though. But you don't only do this with electric vehicles. You see other ways of reducing the fossil part of reduction. Of course, there are CO2 coming from any combustion, but if we look at compressed biogas, liquefied biogas, there are great reductions compared to using fossil diesel, also from HVO. The BEV is on a lower number, actually, and that's because that we are calculating not of ideal electricity, but the European mix. So still we see, yeah.
I'm sorry, Niels, for just a quick interruption. I'm very sorry. It appears as though your screens are flipped. You're sharing the present, or not the presentation. You're sharing the control screen.
Okay.
So if you could switch, that would help. So it'd be a little larger for them. Thank
you. See how I do that then.
Oh. Is it that one there?
See all pictures. No, it's not. Visningsinställningar.
Yeah, mine were there for, yes, there you go. Switch screens. Perfect.
So sorry for that.
Thank you so much.
Okay. So now it's complete black. You see now you see
yes, it looks good now. Full screen. Thank you.
Thank you for nothing. Right. Why are we very focused on electrification and especially trying to do electrification from direct electrification? It's very much about energy efficiency, energy consumption. If we go for the green electricity, it's not a surplus of that in the world. Then we need to be very efficient using that. And here you see why this is a major pathway at the moment, go by electric, is that we can directly feed more than 76% of the electricity from production goes directly into work in the vehicle. This path includes stationary charging, but also could be charging over electric roads. So by mentioning there is a very much lower efficiency going over electrolyzed hydrogen, and if you try to do an e-fuel or e-gas, you are even losing much more, like 4/5 of the energy is lost. So is there a business for this, for the customers? Yes, it's will be. It's not there yet. But what we see also is very promising is that on the long run, there is a reduction of total cost of ownership for BEV, even in long haul. And you can see here when we hope that's come out so you can see it, but in 2030 compared to some early stages like now, there is a 10% of reduction. It doesn't sound much, but 10% in this industry is like 10 years of development to get the combustion engine to be made more efficient, or even 15 years. So 10 years of cost reduction, energy reduction, and so on. And here you see naturally that the vehicle in 2030, the vehicle part of the total is higher, larger. The driver cost, as long as we use drivers, is the same, but energy very much dependent because of efficiency, it's very much lower. And over time, with batteries coming down in prices, volumes goes up and so on, volume effects, we will see an even better business. So again, we aim for this electric, and we have a roadmap to complete the portfolio. Somewhere close to 2030, the complete portfolio customer need will be full. So our spectrum of what the customer we can offer the customer is complete. And we also say that Scania has a target to sell 50% of our new sales will be electric. And that's hefty, as we today from Scania have approximately 1 or 2% in 2024, full electric. Consider that. Okay, how to feed all those babies or big trucks? Yes, we need some sort of infrastructure, and what's sort of the talk of the town is to go for megawatt charging systems. So there's a big work on that. That's stationary. We need at least up to 700 kilowatt hours of energy per truck in long haul, and that is to give sort of autonomy, if you could call it, for 400 kilometers. But the second thing is that to make the ecosystem work as it is, at least today, you need to charge very fast, and do that also connected to your rest periods, legislated rest periods, which is 45 minutes every 4.5 hours if you're a driver in, at least in Europe. So for that, you need to push in up to 1 megawatt into this truck. Question, how many of those megawatt charging systems do we have today, and how many do we need? Today, we have 0. None. In the whole Europe, there exists 0, and that's very much because the standard has not been fixed yet. How many do we need? Well, maybe not of the megawatt charger, but we need something like 77,000 charging spots, somewhere 2027 to 2030. 77,000 charging spots, not for passenger car, but for heavy trucks with trailers and everything. So I can say this infrastructure is not in place. Alternatives. voila, look at this. Electric roads. And there are many of them, and we have had long and very good collaboration from Scania with different companies. I just mentioned two because there are pictures also here of Scania truck on the electric road conductive from Siemens, and also inductive, Primo, formerly Primo, now NRX. And those are old pictures. We have been doing this for a long time. Okay, electric roads. Are there anything called electric road vehicles? Well, I say no, there is not. There is not a vehicle called electric road vehicles from Scania. You cannot, and you will never be able to buy an electric road vehicle. Whatever, you can buy a truck, which will be adaptable to be on an electric road. And this is the whole trick of the story here, is to make up a modular product system, which includes also electric road ability. Stationary charging could be biofueled, not the same truck, maybe with stationary charging and electric road, but usually a full electric truck will not be able to have a combustion engine. So, but by doing this, we will see trucks able of being ICE, but probably not very many of them driven with fossil fuel in the future. But it could be hybrids, plug-in hybrids, battery electric vehicles, and also fuel cell electric vehicles. And if needed, they are connected to charging ability. So electric roads then. We have been working very, very long time on this subject of electric roads. So we can now state clearly that the technology works. It doesn't matter more or less which type of, all of them that we have been involved in and see being developed, they work. But and we can also say that we have been mostly involved very much so into the conductive one. And what we say, going back to the former picture, the integration of this system, which is sort of a big charger, which make you able to charge while driving, it's simple. It's sort of engineering excellence simple. We look at it as very much possible and also simple. Even so, the economy is good, and still it's not happening. And that's basically one of the reasons, is that the ecosystem is very complex. Has many actors, very many actors that need to come together and make this happen. So we state now that technology is not a challenge for scaling. There are other factors. We also continue on saying that Scania has a commitment to this. It's not the solution. It's one of the tools in the toolbox of many, but it is possible. If there will be an electric road, there will be electric Scanias on that, and charged or taking the energy coming from either from below, inductive, from side, whatever, it doesn't matter. We can support electric road system, and we will have a solution to the market need when there is a market coming. So I think I end there and say, if you would like to know more, you see my contact data here, and can also go in and read much more about our journey in sustainability and also electrification and directly into electric roads. Thank you very much.
Niels, thank you so much for that. What a great recognition, not just for the country of Sweden and their participation for ERS, but also Scania and their goals moving forward to become not just sustainable in your own operations, but championing the effort both with your customers and with other communities.
Thank you, PT. It's not just what we say, we also actually do this. Even though we're not very proud about the volumes of electric trucks at the moment, we're not. But it's not the only solution. And it's a long journey. We need to make it faster. And electric road would be one of very good in different or various areas would be a very functional solution. But we need to speed up the pace.
And that is one of the two elements between our both of our speakers that I find most fascinating is the passion that both of you hold towards sustainable mobility. Your comment before about working in the space before it was called e-mobility made me chuckle a little bit. Not so much chuckling that you noted my 3 decades of time that pales in comparison with your resume, but we look forward to doing more work with you, and Scania was really a great opportunity to see some of your operations last year. So to the folks online, please feel free to write in questions to Niels. But of course, I have 1 or 2 that I can start things off with. Because of the familiarity that Scania has, not just with dealing with customers, and when we say customers, of course, we're talking about fleet buyers, right? Truck buyers, not necessarily the drivers, not necessarily the end customers who need the freight moved.
Mm-hmm.
There are many technological challenges for each part of the ERS system. What would you see as perhaps the most likely architecture that would be a first larger than pilot scale deployment in ERS? And I have the short list, of course, which would be, one of these systems on their own or one of these systems with catenary. You have a full BEV. You have a hybrid truck with or without catenary. And then, of course, the fuel cell vehicle.
So which vehicle combination that's will happen there? I try to enforce my message that for us, Scania, that is, maybe not for the industry, it really doesn't matter. Because for us, the architecture is more or less the same. If there is an electric powertrain and some sort of a battery, it can go on an electric road. And this comes a little bit into the historic change from the beginning, as sometimes I say this, maybe it's a bad saying, how to say, but I said we invented this thing, this animal was invented too early. And we invented it in a way that there was no possibility to drive a long distance truck on batteries. Maybe if you were hauling potato crisp, potentially, someone said. But at the time in the beginning, it was other reason. It was not possible to utilize electricity for long haulage trucks. That is possible now. And we support and we will sell solution where we have MCS, mega charging system solutions, and they will work. I think electric road systems will come back in place where we find out the problem of scaling this to 100% transport system electric. That is when this happens. And that will be absolutely electric vehicles, full electric BEVs in the long run. And I think it's already so. So the architecture, if there is an electric road, is probably a BEV, BEV, battery electric vehicle. I hope I answered that question.
No, you did. Absolutely. It was a good answer. And I do absolutely respect your insight as an OEM provider to be flexible. It was probably one of the more interesting pieces when I had the opportunity to visit your operations in Sweden to recognize the ability of your company to move quickly to meet the needs based on modular platform. And that, of course, is the speed of business, as they say, right? Being able to respond quickly and meet the needs of the customers. As we move forward and we talk more a little bit about electrification, one of the things, of course, you brought up was, if we're talking megawatt charging, which currently there are very limited numbers of those. As you mentioned, there's no standard quite yet. It hopefully will go to vote again soon this year. But the next question then becomes the power. During our Task 47 meetings earlier last week, one of our speakers talked about the fact that if you had, at port, a ship that is connected to the grid, You have a couple of trucks that are, connected to megawatt charging, um, and, a couple of other activities for on import electrification activities. You're going to be pulling in, 7 or 8 megawatts of power just for those things. That's enough power to, change a grid controller's distribution logistics, depending
Yeah.
upon the size of the grid that also supports, land-based, not just operations, but personal dwellings. Do you see the grids growing in support to meet the needs along freight corridors? I know that's a little bit out of your scope, but is this something that you guys are recognizing as a not a challenge, but an opportunity to look differently at electrification of freight?
Well, this is one of the main topics that is absolutely on the scope for a company like Scania. I mean, if we had the world's best electric truck, but there is no possibility to charge it, it would be the most stupid product. So of course it's on the topic, how will the infrastructure support it? And I think it will be, it's like when you look at the camera where the telephone 15 years ago, which has VGA resolution, VGA, and then now it's megapixel. No one talks about the millions of pixels anymore. It will be the watt or the megawatt or the many megawatt of charging will not be an issue to talk about in the future. And that's a necessity to make this happen. But it is so today because the infrastructure is not adapted to supporting mega charging stations. But if you make it a little bit less dramatic, you'd say that a mega charging station, it's like a factory. It's okay, it comes in trucks and they need 1 megawatt, 700 kilowatts, and then comes another one, and maybe 4 at a time. But it's like a factory that needs power. So a set of megawatt charger stations in a country will be like a set of factories that need electricity. So it's not very strange. Maybe they are the grid is not located the way we need it. So, but I will say before I stop and you stop me, one thing about power is also connected to the electric road. Many years ago, where we were very much focused on hybrids, we were saying that we need a heck of a lot of power also from the electric grid, because of course there is only a need of 100 kilowatt as an average, but no truck drives on average power. You need up to 600 kilowatt of power on the wheels. But when we have batteries, and we also have a grid network, and every BEV will also have a secondary charging, even if there is an electric road. Think about this. If you could only support to have the battery at the same SOC during a longer transport, if you just can support the battery, then you don't need anything more than 100 kilowatt continuous in an electric road system per truck. And that is a marvelous thing. Of course, you will have a need of 600 kilowatts sometime, but you take that from the battery. You don't need that from the infrastructure. So you have, if you have zero depletion target of batteries in long haulage, you only need 100 kilowatt. And that sets possibility of, well, if you say wireless charging with 100 kilowatt, that is possible. Wireless charging continues with 400 kilowatt. That is maybe not at all possible. But continuous charging 100 kilowatt, yes, possible. Sorry for extension there, but
No, that's very good. That's great information. I apologize to folks that I'm typing. I'm still trying to connect Jan to the webinar. So we do have another question with regards to one of the slides you showed. It had some less efficient elements when you consider hydrogen in the closed circle. And yet the question was raised, there's a fair amount of money being spent in that area. Just looking for a reflection on your take on hydrogen. I will put in a quick comment because in the United States, we're also spending quite a fair amount of money on developing hydrogen hubs. And I do recognize that hydrogen as an energy carrier adds to the flexibility, which all customers appreciate. And I think that depending upon whether you have nearby energy storage systems, which could be batteries, the power comment that you just made helps to identify that if during off-peak power times, off-peak electricity demand times, you could be producing either hydrogen or some other energy carrier that helps to balance that grid load and it provides flexibility. But do you have other insight with regards to, hydrogen in a vehicle? And even though it's
Yeah.
not the most efficient round trip?
It's physics, so I don't have other insights than others. It's not as energy efficient if you take the energy to produce it and then use it. That's fact. But I'm not saying that it is not a solution. It's not the solution, but it is a solution. And in some areas, for some consideration, it might be that you even see a surplus of fossil-free hydrogen because everything else in that area is driven by hydrogen. Your trucks, your local sort of factory trucks and equipment and everything, and you have hydrogen as a process gas anyway. Well, I'm not saying that it's stupid, but I think very much of the flexibility you're talking about is sort of a dream to come back to the diesel flexibility. I mean, the flexibility of diesel is tremendous. We will never see, I will say that, we will never see something like that if we don't go to nuclear trucks, maybe. But if we're not doing that, we will not come back to that flexibility. You could store 1,500 liters of diesel in a truck and you buy it where it was cheapest in Europe, and then you go for a week in Europe.
Yes.
And you do long haul in Europe with that, and you never refill. It's like buy a truck and sell it when your tank is empty. That's the nuclear one, though. But I mean, we will not see that. And I think we try to make it as it was. We need to think the new infrastructure. Is it a good thing to mimic exactly what we have? No, I think it's very stupid because if you have electricity directly, you can be your own producer. You cannot go and someone can find diesel in the ground and can make it into good diesel and fuel into your truck. But electricity, you can have your own farm of solar. You can have a wind farm. You don't need to be connected to an infrastructure necessary for some of the transport. And that is interest. Try not to mimic exactly the old system. We would not see smartphones if we try to make better telephones from the beginning. We would not have seen smartphones. There will still probably be a much more efficient cable coming from the wall to the telephone.
Well, that's an excellent point, Niels. And I think that you really highlight something here that, as you see it, in a country the size of Sweden, and I'm not going to make size comparisons here with the United States, but if there's the difficulty in getting power different places to meet the needs of the long haul customer, even though we need to move away from the diesel mindset, we still have to have a certain flexibility for those truck providers in particular to meet the mission needs. Obviously, electrified roadways helps to expand the given area for charging ability, but there's still a need for the power for those roadways. Do you think that the corridor focus of an electrified road system helps to bring the opportunity to charge those vehicles into a business case? Or do you see that it's possibly, at least in the near term, more likely that you're going to see static charging help expand electric trucking and then see ERS possibly fill in afterward?
Well, I would say it's my personal idea here, but it's my feeling that it's the latter. It will be static charging first. And again, the motivation, if electric roads comes, the motivation is to trouble we will have to scale up to 100%. Because we are talking about millions of trucks in Europe and US the same. We are talking about the amount of transport needed, and those will not be reduced. So I think that again, I come back to the idea that me and others invented something called electric roads too early. It was when, no, it was not a place. It was the most stupid thing to do. It's even ugly, some people say. So, I mean, it is probably the latter, what you said. It started off with electric, with the small volumes, and then we start to get a heat in our back about the speed and the problem to make the infrastructure handle those hotspots of 30 megawatt continuous charging or peaks of even more for a big European Autobahn charging spot. So well, I'm soon to get into my retirement, but I hope I will see something happen in the near
Well,
years.
we do as well. And to the attendees, I'm very sorry to report that Jan Peterson is unable, due to a firewall block from his company, to get into this Zoom event. We've tried a number of different avenues. So I'm going to not go through his slides entirely because I would not do them justice. But there are a couple that I want to highlight and see perhaps, Niels, you might have a comment or two as the Swedish Transport Administration moves forward toward producing another tender for a permanent electrified roadway system. Both understand a little bit of your insight into that proposal. Obviously, I'm not looking for anything that you deem sensitive, but perhaps a recognition of the partnership or stakeholders that need to be involved to create the right response to the tender. Let me see if I can find the particular slide. I think, well, important for us to recognize, as I mentioned earlier, that Sweden, unlike any country, has actually worked in the technologies in each of the different technology types.
Well, PT, I would say that, of course.
I'm sorry?
Yeah, if I understand the question right, which parties should be involved in the tender? Is that what you're asking?
Yes.
Yeah. And I think, of course, an OEM or preferably a number of OEMs that support this idea of it's not an electric road vehicle, it's a vehicle adapted to electric road. If you support that, I mean, then it doesn't matter if it's Daimler or Scania or Volvo or whatever. If there will be this happening and it comes to being a longer stretch and there will be at least hundreds, 200s, or even more trucks on that, then it's an interesting business. And of course, there will be answer on the tender from a number of OEMs. So OEMs are like, in that case, we'll be supplier of a tool that supports the whole idea of electric roads. I think there has to be sort of a setup where we connect all the cogs into this mechanism. We have the electric grid should be adaptable. So if we find out a stretch, we must go to the electric grid owners along that stretch. We need to find someone that owns this thing. Is it the Swedish government or is it some privately owned? We need to find out how the business about the electric road actually is done. How you sort of pay for charging or using energy and so on, and who is responsible. Trucks on that, is maybe one of the least important things we are able to deliver, but we need an infrastructure to deliver to.
Excellent comment, thank you. And I will note that we're trying to do a good job of monitoring the chat. So if you have questions, For Niels, please go ahead and enter them there. I will ask another quick question, and this is with regards to, I'll say the previous tender, and I think that I'm properly sharing the map of Sweden, the
Yes,
slide, is that
a
correct?
part of Sweden, as
Yes,
being born
yes,
in the northern part,
yeah,
I
not the good
hate
part for the
those.
Northern Lights, I understand, but the part perhaps for a little bit more of the commerce. The previous tender, and if you can see my cursor, the arrow, was for permanent ERS in this system here roughly, and I can't recall the road name. So it's right in the center. It's a very high traffic corridor. But as I mentioned earlier in the webinar, we also have a task that focuses on port energy. In your perspective, would you see that it's perhaps, or which might be the better choice to go toward an interior high use corridor for the start of an ERS system, or do you believe it may make more sense to be in a more regional, whether it be around a port or around a particular, even like, Paris, a very high density area?
Yeah, no, again, I see that it is a good solution to start and build where you have a sort of a strong partnership, and that's probably in the region. We can build a strong partnership and build it up. And we have for a long time we said see it as islands where you build islands, and then you build a second island and a third island, and then you connect the islands. That could be one way of doing this, bridging from communities to communities where it's relevant, to have the sort of electric road idea as a support.
Well,
Um,
that's an excellent point, and it highlights one of the differences of long haul trucks or even regional haul trucks in the United States versus the EU. For Task 45, we're very fortunate to have one of the representatives from an OEM provider, excuse me, obviously from OEM. We have Krister from Scania, but also from a provider of technology, Patrick Ackerman, who has highlighted to me in the past that in the EU, most trucks usually only will go between 50 to 75 kilometers off of what they call their stem route, so their main course of a major corridor. In the
yeah,
United States, it's very different. We have much more off corridor driving, and often these trucks will do what we call ABC routes, where they don't just go out and back, they go out and then to a number of other delivery points, and then they return.
yeah.
Do you see this having an impact with regards to countries and also, I should say, perhaps policy that might drive this technology?
Yes, I can't tell exactly how, but yes, it has. But anyway, to make business, I think very much of it, if it happens or not, it's political and also set up the ownership of different parts of the ERS road network.
Mhm.
But if it happens because it's a good business. It cannot happen if it's sort of you don't see a truck for days or something like that. You need to set up a business which is interesting with positive business case for all invited parties. And from that, I would say that if you build from that, it really doesn't matter more or less if it's a long routes or if it's very dense traffic, many, many hours and kilometers run from a port to hub. It doesn't really matter. You need to have many kilometers traveled on the electric roads to motivate it. Otherwise, it's not motivated and batteries will be fine stationary charged.
Very good. Well, we've also seen a few areas within the United States for light duty causes for ERS as well. One of those is, I'll say, not necessarily slower speeds, but more urban settings and a place where, as a for instance, a transit bus, which has a route that's very dedicated, could go and basically as it's charging dynamically, it's always opportunity charging. Do you think that the ERS has more likelihood of going into one type of application versus another first, a more urban setting like I just described, or a more corridor route setting for freight? Just a personal insight.
Maybe I'm an engineer trying to be thinking about money, but it is about money. If you have a business, that will set the play. If it's what kind of it's there. And you mentioned speed on the route. If you have a road where network of ERS, you should drive as slow as possible. You know why? Because then you utilize the network as much as possible. If you drive at 90 kilometers, 55 miles an hour, zoom, you pass it in seconds.
Mm-hmm.
But if you have 1 mile and we stay on it, you can even see it at charging areas where you go on batteries, you come into charging areas with slow speed. Look at the road network in Europe. Along the motorways, you see trucks doing 10, 15, 20 kilometers an hour on the furthest right lane. What about if that was an electric road when they, anyway, almost stand still, but they're not really. Charging while doing slow speed, that could be enormous good benefits in economy. So I wouldn't like to tell you, or I don't even have an idea what the animal looks like in the first place. But if it's a good business, then it will happen. If not, it not happen.
Very good. I understand. Niels, I want to thank you so much for your time and your flexibility. I apologize for the technical difficulties for you as well. I know that we were able to at least get a brief glimpse of the Scania perspective, which was very important for me and very valuable. So I appreciate your time, and we look forward to working with you as this ERS technologies move forward. And hopefully, as you said, it's timely for the both of us that we can see something into production prior to sunsetting.
Yeah, let's hope that. Well, let's even work for that. Thank you, PT, and thank you very much for the possibility to be an opportunity for that. And if you set up some more, just give me a call.
Wonderful. I will do that, especially with regards to 2954, the wireless standards as those move forward.
Yeah, thank you.
Very interested in that technology. Thank you.
Okay. Thank you very much, everyone.
Thanks, everyone. I'll be on for a few minutes yet. If there's additional questions or if there are folks that would like us to reach out, please do enter the questions. Niels, again, thank you and have a good rest of your day.
Thank you so much. Bye.
Bye for now. With luck, we'll be able to send out Jan's slides and you can get the perspective from a traffic organization, or excuse me, transportation organization that is actually in charge of distributing the funds to put one of the first ERS systems into permanent deployment. If you have questions, please put them into the chat. And other than that, have a great day. Thank you so much.